So here's my fully populated board. Got all the parts on it. It gets blurry up close, but there it is. All the parts are stuffed on there as neat as I can make them. Again, I didn't put the antenna on there, and I'm going to just manually solder it on later. So now let me rearrange my camera setup here. Let's switch to this camera, which the cat was knocking all over. So here we go. There's our reflow oven of doom. And now I'm going to take this board and put it a little bit out of the way before I mess with the camera that was right above it. It's over there. I'm going to spin this camera around and aim it right at Mr. Reflow. So let me switch to that camera again. So here's my reflow oven, and if I line this up properly, so this is an Arduino microcontroller. And what I did is I stuck if you've ever messed with Arduinos, you can put riser boards on it. So it's got stuck onto it a riser board, which does the LCD display and has buttons on it. So there's little buttons down here. So that's like a $20 riser board. You can just plug right into an Arduino Uno. And then I custom built this other board in between that's got the LEDs here on the side. So that's a custom board in the middle. So there's 3 boards just sandwiched together to make my controller. The Arduino, my custom board, which basically just drives a couple of relays, essentially, and then the display board. And all the rest is the magic of Arduino software. So, and this is attached to my oven, which I'll just back this camera off. Here's my oven. And let me lower this down a little bit. Oops, right idea, wrong knob. And inside my oven, you can see here, there's a K-type thermocouple. And what I'm going to do is bend this around a little bit because it always gets moved around when I move this thing around. So it's going to be sitting just a half an inch or so above the frame. That looks good there. And now I'm going to take my board. And this is where I always sweat bullets. Okay, I'm going to take my board here and I'm going to slowly slide it basically underneath the thermocouple. So that thermocouple is now measuring the temperature just above that board. So the thermocouple is a pretty good indication of what temperature it is by that board. And now when I close that oven, you can't see too well in there, but that's it. So, all right, so now it's all over but the bacon. So hit any key to continue. I'll just read you what it's saying in case you can't read it very well. Let me see if I can move this a little bit closer.
So what determines the reflow oven temperature profile? Is that the brand of soldering paste that you use?
An interesting question. So yes, the solder paste will generally come with a profile. And if you look at the data sheet for the solder paste, they'll have a recommended profile. You'll also find that the manufacturers, for every single part on their data sheet, will probably have a recommended temperature profile to use for silver solder and not for lead solder because they all want to be lead free. When I wrote this software, I actually programmed both curves in here. So the very first question is here, lead or silver. Lead is the 215 degree profile, and the silver profile I think is like 250 degrees. So I got it set for lead, and I'm just going to let it default to lead. And what I've discovered with my oven here is it heats up to the recommended temperature, but it's got a lot of inertia. It takes a while to get up to heat. And what I found is that if I started from 20 degrees C or so, whatever room temperature is, that it would never catch up to the profile by the time the profile was saying it should be 215 degrees. So what I did is I put a preheat function in here where I can preheat the oven up to about 50 degrees. That's not enough to hurt anything on the solder. It's not going to melt it or anything, but it's going to get the oven sort of up above room temperature. And then the oven keeps the temperature profile better. Strictly speaking, you're probably not supposed to do that because it probably dries out the resin a little bit that's in the solder paste, but it's the best compromise I have to just use my $10 oven here. So I just do a preheat cycle. And basically it's saying the current temperature is 19 degrees C and hit a button to start. So I'm going to go ahead and mash the start button. So I have a green LED that's basically on whenever it's got the oven turned on, and a red LED is on when basically I'm cooling and it's running a fan. So you'll see the temperature starting to come up a little bit. So basically it's just going to warm the oven up to 50 degrees C, and then it'll begin the normal cycle, which will actually have it start at 20 degrees C again, because that's the way the curves are written. So it'll actually be too hot at first, and it'll just remain off as it ticks up in desired temperature. So basically the target, it's always displaying the target temperature and the actual temperature in the oven. And right now it's preheating and the target is just 50 degrees in solid. So you see I went above 50 degrees, so the light went out and the oven turned off, and the oven will actually coast past the temperature. So now it's started the curve, and you see the actual target, that's actually now running the curve for reflow. And so it's going up, but the oven's already like shot past that. So the oven's just off waiting for the curve to catch up. And again, this isn't ideal because it's probably warming that rosin a little bit and causing it to dehydrate a little bit. So, this isn't perfect, but for given how many different ways you can do reflow soldering, this isn't bad. And you'll see as we get to the higher temperatures, it tracks pretty well. I'm checking every half second whether I need to turn the oven on or off, and adjusting as appropriate. And I think every 2 seconds, the curve, I don't have every half second temperature in my curve. I think I have like every 5 seconds in the curve, just to make the array of values not crazy. But I interpolate in between. So if I know I'm supposed to be at 10 degrees in this 5 seconds and 15 degrees in that 5 seconds, 2 seconds from now, I know I should be a temperature in between. So I calculate those. So our target is now above what the oven is. So the target's going up, but now the oven hasn't turned itself on for a while. So now it's got to catch up. Wait for me, wait for me. So it's a little bit of a game here. So it usually runs about 10 degrees behind here, but it is running a curve at about the right speed. It's just a little behind where the curve wants to be. So just so you see what the oven looks like, if I turn the right knob, the oven, go down low enough, you can see the elements down below are red. It's heating up. So every now and again, when it turns the oven on, it's a little pink in there.
Now, is silver solder a little harder to work with? Is that why you prefer to use the lead?
Silver solder, yeah, I prefer to use lead because it works cooler. If I have to do repair, mostly because of repair work. There's always something, you got to take a part off, you got to swap parts, something didn't reflow properly when you built it, whatever, and you got to work on the board. And when you have to deal with silver and you have to heat everything up hotter, you risk damage to the parts, you risk damage to the board if you overheat the board, because I do all that work with hot air. And so you're blasting hot air on a board and just heating everything up a lot more. And it goes through more thermal shear up and down. And I just think it's harder on if as I often have to do repairs on these boards, I just think it's a little harsher on the boards. And as I say, I'm in an age where I'm not really concerned about handling lead and getting a little lead on my fingers. I ask the students who work with me to put gloves on and stuff when they do this. I'm not going to worry about it. I'm not planning any kids anytime soon. And like I say, a little lead poisoning is not going to kill me at this age. So work at your own risk. So you see up about 150 degrees or so, it keeps up pretty well, which is sort of surprising. At the hotter temperatures, it does a better job than at the lower temperatures. So it's staying in the range. And this whole curve takes about 12 minutes or so, I think. So we're coming along just fine here. So it gets to a certain temperature, and then it sort of sits there below the melting temperature of the solder. And what it's doing at that point is just holding the temperature to let everything come up to heat. So I think they call that the soak. And I think this might be the soak if it's sits around 180 for a little while. It might be a little warmer. And then you'll see all of a sudden it'll spike up to 215. So it holds at a certain temperature below the melting temp of the solder, getting all the parts as hot as possible, letting the whole board get up to heat. And then it spikes up to 215 to melt the solder. Everything moves in place, and then the temperature drops like a brick to freeze the solder. So on my oven, yeah, the temperature is going up now. So you really can't, I can't even see it looking indirectly, so you won't see it with the camera. But at this point, if you look in there, if you can see well, you'll see the solder get shiny and melt. And now you see we're up around 215. It's going to hold up here for about 10 seconds, and then the temperature is going to plummet. When that happens, it turns the fan on my oven. I don't have enough airflow in this oven, so it doesn't cool fast enough. So what I end up doing is cheating and holding the door open a little bit too, just to let more cool air in so that it cools fast enough. So yeah, there we are holding at 215. We shot a little past it, so we turned it off. And here we are in cool mode. So now we're cooling. So I'm going to crack the door open a little bit to help it out, because you see this temperature is going to drop like a brick, the target temperature. And so to keep up, I have to crack the door open. So at this point, that solder is frozen. And now we're just cooling the board so it doesn't, you know, crack or anything. We're cooling it relatively fast.
I'm kind of surprised that this didn't take nearly as long as I would have expected it to.
The reflow part?
Yeah, yeah.
Yeah, it really doesn't. The curve takes about 12 minutes. I mean, yeah, most of the drama is about putting all the parts on the board. And then, of course, the testing, which will take me days, you know, from here out.
Sure. Especially if those diodes are in backwards.
Yeah. Yeah, two of them, you know, one of them I know is right. The other two, who knows? So I'll test those first thing. And that's pretty easy to do. I'll just hook a ground to it and put a 3-volt power source to the pin that lights it up and see if it lights up. If it doesn't, I'll take it off with hot air. So now you can't quite see on camera, but I've got the door held pretty wide open. Let me switch cameras here. Yeah, I'm holding the door. You see how much I'm holding the door open to keep the temperature curve. My actual is 89 degrees. The target is 75 degrees. So I can probably pretty much just leave this door open at this point.
So you need a servo and a little arm to open the door and modulate.
There you go. Yeah.
Yeah, you know, I've got one fan here on this side, and I've got a, you know, what is that, 3.5-inch box fan there. I'm thinking, and this one's blowing out. So I'm thinking of putting another one on the other end, pushing in to just move the air. Because right now it sort of sucks the door. It has some vents in the back, but they're small. So mostly it's sucking air in from the front and blowing it out the back. If I had another fan on the far side, but all this, all the knobs and stuff are on this side. So getting the air through there might be a hassle. So yeah, I actually did consider literally putting a servo and an arm on there just to open the door. But again, I don't do this all that often. So, you know, holding the door there for 3 minutes during the cool cycle, so what, you know?
Yeah.
Not to mention you got intelligent temperature feedback too, so you can modulate that door with your hand as you
right,
and probably do a better job.
Yeah, and I have that, you know, I had that door pretty wide open. So you see my little thing says reflow complete. The fan will just run for another 30 seconds or so. But we're done. So we can hit the any key. So now it's just a matter of reaching my hand into that oven and grabbing that board. And let's rearrange cameras again. So there's my board. And let me get it under the microscope, because that's probably going to be more useful to look at this point.
What brand of microscope you already using there?
I don't even know what it says. It says pluggable.
Okay.
I bought it years ago.
Yeah, I've
Picked it up on
seen
eBay
those.
or Amazon, I think.
Yeah, really inexpensive too, from what I saw.
Yeah, it was like 20 bucks or something. It was really cheap. And it works just fine. except right now where it's there we go. All right, so let's take a look at things. So there's one of my diodes that looks on there nice. That resistor looks good. 330 ohm resistor, that's sitting on there okay. Those all look nice solder joints. Moving over. Now that capacitor didn't turn itself around, but it's on there okay. That temperature sensor looks like it's on there perfectly. Those resistors are beautiful there. Capacitors look good. Those caps look good. Resistors look good. Having to move all this backwards. Oh, there's our big chip. So yeah, that looks great. That looks like it's connected perfectly. So there's all our other, there's our crystal that's on sideways, and that looks okay. Some more resistors, and my filter network over here. And I think everything came out just great. So that's Reflow soldering.
Cool.
Nice job.
As I said, it's all over but the testing. Let's see if it actually works or not.
Well, that's pretty cool.
Well, I hope you enjoyed that.
Absolutely. Yeah.
Definitely.
Really appreciate you going to the trouble to do that.
Yeah, so for me, the next steps are going to be, I did test just to make sure. Let me put this camera on. No, I haven't shown you guys. Oops, wrong camera. Not you, you. Okay. So here's the board that this is intended to sit on. And what I looked at a while back was, when these first came in, is using normal riser pins. So here's like a normal riser pin setup. And if I put these pins in the holes, whoops, that's actually one too long. But if I use those pins, what turns out is, if you look at the end of this, this is actually the Bluetooth antenna right here. And using a normal riser, this ended up basically mushing down to the Bluetooth antenna. Oh. So what I looked at doing was somewhere where I wouldn't lose them, here they are, is I just took a stack of these riser pins and slid the pins out and doubled them up. So you see that's two sets here.
Yeah, nice.
So if I put these double whammies in here, so, you know, I'll solder those down to the board and then put this board right on there, and it just fits like a glove right there. And it's got clearance around that Bluetooth antenna. And oh, you see, I didn't take the solder paste off, so there's the solder for this other antenna, and that just sits right next to this one. So I have two SMA connectors right here. So that's how that's going to look. So, but before I do that, what I think I'm actually going to do is put singles on this board. Because if I put singles on just like this right now, I can stick this into a breadboard, and I can do modular testing on the breadboard. Because if I have anything mixed up and shorted, I might damage this microcontroller board. So I can do some basic functional testing of subsystems on the breadboard, and just breadboard connect it to this or a different one, make sure things work, and then when I'm confident that it's not going to hurt anything, I can solder it onto this one. Or if it's such a train wreck, I need to order and redesign it and order a new board, it's easier not to have it built on here yet. So that's my plan, is to put these headers on there, put it on a breadboard, do functional testing, and if it's all good, put it on there.
Excellent.
Yeah.
And then it's all over but the software.
Thank you very much for sharing this. This was great.
Indeed.
Cool. Yeah.
I'm glad you enjoyed it.
And now let your poor cat back in.
Yeah, my wife just took him away, because even in here, she was trying to hold him, and he's just like, no, I don't want to be held. Dad's doing something fun. I'm going to go over there.
So Mike, when are you going to build your pick and place robot to put those surface mount parts on?
Oh, I am the pick and place robot. So, geez, looks like we had a whole bunch of folks from various ham clubs, but none of our students showed up. That's a shame.
I was going to say, all your students got a lot older.
Cornell students aren't as young as they used to be, I guess. That's okay. I'm recording, so we So it's all good. Yeah, for as many of these as I do, some of it's the joy of it, right? Like I like bowling, I like the precision. So it's another precision sport here to work on. So, but what really puts hair on your chest is when you have to do, rework on these to fix them if there's a problem. Like that diode. If I have to take that diode off, that's a whole other video. I use hot air for most of that kind of work.
And you got a particular brand of rework station that you like to use, or?
Well, yeah, cheap. Cheap is my favorite brand.
Okay.
I have this is an Xtronic. Again, if you just search it on Amazon, I think you'll find it. It's an Xtronic.
That's what you have too, isn't it, Raj?
Yeah.
Okay.
Let me swing a camera. Actually, if I switch to that camera view, let me go ahead and share the camera again. Switch cameras. Here we go. I just give you all vertigo and move over to my stack of, if I aim it properly. So this is a cheapy Xtronic 4000 hot air station. It actually has hot air and a soldering station. I found the soldering iron so awful, I just took it out. I have it unplugged. I never use it for soldering. I only use it for hot air. But for hot air, it's great. So I love working with hot air. If I have to do a repair on a board, even down to 0402, I'll use hot air before I'll use the soldering iron.
Really?
I'm much more comfortable with it. I'm much more accurate. And since I'm so brand loyal, I have, my favorite brand is cheap. I've got a Heiko desoldering iron. Let's see if I can pull it out of here. Wow. So if you've never used one of these, this is awesome. So, whoops. So it's basically got a soldering iron tip and you pull the trigger and it's got suction. So this is great for desoldering stuff. I picked this up actually at Hamvention when I was in Dayton. There's a guy had this for a reasonable price. It's three versions ago, last version unit, but you can still get parts for it. So that's my hot air solder sucker. And I would say of all the devices, this one's not all that great. The Heiko, it just doesn't have the suction I really would like. And I'm a Metcal bigot for soldering. I use Metcal for soldering. So, and I've got a Metcal has, you don't really set a temperature on the thing. You buy tips that operate at different temperatures. And I swear by Metcal. So I use Metcal for all my soldering. And I've got a super fine tip that'll work with the Metcal solder station.
I'm curious what you use for part storage for those tiny little components.
Oh, well, if we look across my shack, I was demoing my shack earlier. So there's my test gear. There's my 3D printer down there. But across my shack over there is my, that's the bulk of my part storage. And all these little boxes with the labels on the ends are where I keep my surface mount. Let me go grab some. So again, my wife and I are big fans of Joann Fabrics because they have 50% off coupons for everything. So this is like for embroidery floss. And it's my 0603 inductors box. So what I love about this is it's got separate boxes for everything. So what I usually do is you'll see right on the in the box, I cut off the label from DigiKey, which has the part number. And you can't, it's blurry in the camera, but there's the part number and the value of the part. And I cut the strip of parts, and you can see the strips in there. I just cut them to fit in there, and I just cut a bunch of them and stuff them in there. And so if I need a particular value, I can root through my box, find the values I need. I pull out these little boxes, and then I do the, peel off the little paper on them to cut out the individual components. But these are all 0603 inductors, so I bought an assortment. And again, most of these boxes, all those parts in there are like $2 worth. So basically, whenever I need a value, I buy $2 worth, and I end up with a million extra parts for the next time. And
Nice.
like I've been doing some filter design, so I just bought an assortment in the ranges that I wanted, where I knew I could build filters for UHF, VHF, that sort of stuff.
Okay.
And so I've got boxes over there. I think my 0603 resistors take up like 3 boxes just for 0603 resistors, all the common values that I use. And I've got 0805 and 1206 larger pieces. So if I'm doing repair work for those, I usually don't build my own boards with those because I'm actually very comfortable. You saw me working with those 603. I didn't spend a lot of time putting those parts down, and I can see them fine. So I like to work in 0603, and the parts are cheap. When you go to 0805 or 1206, they're bigger parts, but they charge more. So instead of getting 50 for $2, I might get 5 for $2. So I love 0603 because it's cheaper. My favorite price. But I buy the bigger parts. I bought the most common values. So I'll have like 1Ks and 10Ks and 2.2Ks in the other sizes, just so if I'm repairing something and I need a big cap or a big resistor or whatever, I'll have it. So that's all my storage over there. So I have, a pretty good set of 0603, 0805, 1206, anything. And then the boxes on the right-hand side are all mostly through hole. Dips and things like that. And then the boxes with the purple lids on there are full of through hole resistors and capacitors and inductors, my through hole stuff. And the big cardboard boxes on that to the left of those purple lidded boxes are my big caps and resistors for using the old timey radios repairs,
Okay.
the big electrolytics and stuff like that. And then those little boxes down below, or those tall boxes with the colored boxes inside, those are other things like microcontrollers and patch cables and things like that just store neatly that way. So that's the brunt of my part storage over there.
Very nice.
And the rest of my shack over here, I've got my workbench over here, which is kind of a mess because I pulled a bunch of crap off this table, so I had room. So there's a workbench over there, and more storage for ham radio gear and parts over here. And then my closet, which has a whole bunch of remote control foamy stuff, and then we spin back around to where I am over here. That's my ham shack, which is notably absent in any operable radios. I have no radios here. I don't rag chew. I don't talk to people. I build radios. I repair radios. I don't actually operate them very much because I'm weird that way.
Fair enough.
So a couple chat messages here. I think Kyle said, or Chris, many thanks for the demo. No idea what went into the whole design and baking process. Really impressive. Have to QRT 73. Okay, so Chris had to take off. But okay. Well, if you guys ever have any questions about this kind of stuff, I love doing this surface mount stuff. So by all means, if you decide to get into it or have questions, let me know.
Will do.
You should all have
Thanks
my
for
email.
letting us look over your shoulder.
Oh, my pleasure.
Yep, sure appreciate
I've been
it.
jonesing to build this anyway because the board just came in last Friday and it's like, I want to build these. But so many people have asked me so many times to see it. It's like, this is a good opportunity. So I might as well get on Zoom and do it.